person, or you can say only person. Once having this title, you have to assign some X label, some Y label as well. So here I am going to say my X label is nothing but, let's say, my room type. So here I am going to say X label is nothing but my room type. After assigning your X label, you have to assign your Y label as well. So my Y label is nothing but, let's say, price in euro. So here I am going to say price in euro. After having all these steps, what you have to do, you have to simply show your matplotlib visual. And here you have one more function, which is exactly your ligand, because you have to show ligand with respect to your resort as well as with respect to your city hotel as well. So if I am going to execute it, you will see this is your amazing visual with respect to each of your room type over here. You will see this blue distribution is exactly your resort hotel, and this orange one with respect to city hotel. But you will see the middle line is exactly your median, whereas this top one is exactly your 100th percentile data, and this one is exactly your 25th percentile data, and this one is exactly your 75th percentile data, and this lowest is exactly your 0th percentile data. So you can easily conclude from this, yeah, the best distribution with respect to city hotel is almost with my G room type, whereas if I will talk about with respect to my resort hotel, so the best distribution of price is almost 10 to with respect to this H room type. And whatever data point that you will see over here, these are exactly your high values, or you can say these are exactly your outliers. So you can definitely conclude as much as you can. So that's all about this session. Hope you love this session very much, and if you have doubt, just post your doubts in your Q&A section or via your personal mode of communication with me as well, whatever you want. So thank you, have a nice day, keep learning, keep growing, keep practicing. Hello all, before all have done till now in this session. So in the very first session, we have collect our data, then we have prepare our data. For your machine learning, whether it's your deep learning or any kind of project that you are. And after it, in the last session, we have this amazing choropleth map, which is exactly we have analyzed. This is exactly your home country of guest. After it, we have analyzed what exactly is the distribution of each and every room type. That's what we have done in the previous session. So in this session, we have this amazing problem statement. How does the price vary per night, or you can say how does price per night vary over the year? You have to consider this problem statement with both resort hotel as well as for your city hotel. It means you need two data frame. So very first, I'm just going to say data of hotel is equals to, so here I'm going to say is equals to, the very first is my resort hotel. After it, so I can say this is exactly my first condition, and once I have this first condition, then I have to add my second condition as well. So my second I'm just going to copy this from here, and again I have to just paste it. This time I am going to say here I have my city hotel. I have done all these things. The second data frame I am going to say this is exactly my data underscore city, and we have to just execute. So these are exactly your both data frame that you have to consider. Let me show you a quick recap of how this data frame looks like. Let's say I am going to check a preview of data underscore resort. You will see these are all your entries vary over the year. So let me check how exactly your price vary over the month, because this is exactly similar to your problem statement. So for this, what we have to do, you will see here you have a arrival underscore date underscore month column. So you have to consider this column, and you will see here you have lots of features in this arrival underscore date underscore month. It means you have to group this feature. You have to group your data frame on the basis of this feature. So here I am just going to say data underscore resort, and I have to access basically my this arrival underscore date underscore month, or what you can do, you have an alternative for this one. So just call group by, and in this group by I'm going to call my mean over there. If I'm going to execute it, you will see with respect to April, you have that much reset underscore index. That's it. This will give me my amazing data frame. Now let me store it somewhere else. I'm just going to say resort underscore, let's say hotel, and after it what we have to do, let's say I'm going to print it as well, which is exactly this one. Just execute it. This is that amazing data frame that you exactly need with respect to your resort hotel. You have to follow this similar approach for your city hotel as well. So I'm just going to say I have to, let me just copy all these stuffs and let me just paste over here. I have to do similar approach for my data underscore city. So just remove on the basis of this arrival underscore date underscore month, because in both data frame you have this common column name. So for your merging purpose, you have to just call some inbuilt function of pandas. Your merge function will be very handy over there. So this time I'm just going to say resort underscore hotel dot merge, and you will check all the custom parameters of this function. There are tons of parameters in this. So you will see here you have a right. It means what exactly is your right data frame. So my right data frame is exactly my city hotel, and this resort hotel is exactly my left data frame. And here I have one parameter which is exactly on. It means on what column basis you have to manipulate my column names. So let me very first store somewhere else. So I'm going to say this is exactly my final, and once I feature I am going to consider it is as month. The second feature I am going to consider it as, let's say, price for resort. The third feature I'm going to say it as nothing but price for city hotel. So I'm going to say price for just print this final. That's it. Just execute. This is your amazing data frame. Still, you have to do one more pre-processing on this data frame. Hope you all guys get to know about it. Yeah, this is exactly that month column, because you will see hello all. Before have to do one more pre-processing on this data frame. Hope you all guys get to know about it. Yeah, this is exactly that month column, because you will see in this month column you don't have a proper hierarchy, and if you are going to conclusion, because this month column isn't in proper hierarchy, you will see April, August, December. It makes if you are going to write your own logic. So yeah, Python is going to be pioneer over there. Python provides you some inbuilt function import, and you have to install it. If you haven't installed it, you have to install it as well. So if you haven't installed it, you guys can install using pip. So this is exactly that module that will come into existence, and it has some dependency package as well. So if you haven't installed that, and weekdays, so you have to also install it. But very first you have to install this one. After it you have to install this one, because this is exactly our dependency package of this one. So if you haven't installed it, you guys can simply install using this pip. So after doing all this stuff, I have to simply import it. So I'm going to say import this short underscore date frame by data frame. Now what we have to do, we have to, let's say, create some function short underscore data, and whatever parameter sort underscore data frame by month. Just press shift plus tab, you will get all your documentation. The very first, what exactly your data frame, and the second one, what exactly your column name. So here I am going to say it is nothing but short underscore data. So here I am going to say this is nothing but my df, and this is nothing but my column name. That's it. And here I have to say column name. That's it. I have to simply return it. So I'm going to say just return all this stuff. Execute it. Now what you have to do, you have to call this function, and this time you have to use your final data frame. And this time what I'm going to do, I'm just going to say I have to short my month column. That's it. Just execute it, and it will take a while, and return this amazing data frame over there. You will see this month column gets shorted right now. Let's say I have to store it somewhere else. Let's say I'm going to say this is my final data frame that I have to consider. So let me just print again, and this is exactly the data frame that you need. Now what you need, you need some visuals so that you can conclude from this data. So whenever you have that type of data, whenever let's say someone will ask, yeah, what exactly the trend or how something is varying, it means the best approach will be just go for a line plot. So here I'm going to say px dot x-axis. I have to just pass my month, and definitely on y-axis I just need some column. So let me say final to assign you some title as well. So here I'm going to say title is nothing but, let's say, room price per night, or you can assign that's it. Now what I have to do, I have to just execute this cell. It will take a while, but it will return us amazing trend over there. You will see with respect to this one you have that much trend, whereas with respect to your resort hotel you have that much trend. Let's say I have to conclude from this line chart, so I can clearly says, yeah, it clearly shows that prices in the resort hotel are much higher during the summer, and you will see over here the prices for the city hotel varies very less, and it is most expensive during basically my spring and basically my autumn column. So that's a type of conclusion you can fetch from your data or fetch from your visual. I hope you love this session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hello all. In all our previous session, we have learned much about decision tree. We have learned entropy, information gain, pruning, and different types of algorithms for decision tree. We have learned much some use cases regarding that. So in this session, we are going to learn how decision tree works. To I have something 100, let's say 10, let's say this 40, this let's say 60, let's say this is 70, let's say this is 200. Similarly over here x3 as well, I have something 70, 80, something 90, something let's say 60, let's say something 40. Similarly something I have 21. Similarly in target variable, let's say I have to predict something. Let's say it is 0.1, let's say it is 0.2, let's say it is 0.9, and let's say it is something, any value you can consider. Let's say some values you can consider. Let's say it is 0.8, and let's say you have some new data. Let's say this x1 actually range between 4 to 10, and this actually ranges between definitely 1 to 500 something. Column this x2, let's say I have to split this column x2 which has a range of 1 to 100. Let's say I'm just assuming it. Let's say I'm going to split it. Let's say the very first range is 1 to 20, second range is 20 to 40. Let's say this range is 40 to 60, and let's say the last one range is exactly, let's say 60 to 100. Let's say this is how I split it. Let's say I have just assuming it. So if I have to write range, let's say if with respect to x1, if I have to split it, let's say the first block I'm going to split it 1 to 5, let's say 6 to 10, the second split. Similarly with over here x2, I have split it in this various blocks, 1 to 20 block, the very first one. Say as it is, let's say the first one is 1 to 100, the second one you can remove this, you can remove all these things. Let's say I'm just going to consider 3 splits, not more than 3. Let's say I'm also going to remove this. Let's second one is exactly my 100 to 300, and it is definitely 300 to 500. Let's say this is my all these things, so it will definitely be 100 to 300 and 300 to 500. Let's say these are my all these splits. Similarly with x3 as well, let's say first is 1 to 30, then I have something 30 to 60, then I have something 60 to, assume it, 200. Let's say these are my number of splits, number of, I can say, blocks for different features. Let's say these are my number of blocks for different features. Let's say I have to predict for what if this x1 is 5, what if this x2 is 200, what if this x3 is 21. Let's say I have to predict for this. So you will see this 5 lies in this quadrant, whereas this x2, this 200 lies in this quadrant, whereas this x3 where it is 21, it will definitely lie in this quadrant. So now what we have to do for this x1 block, we have to compute the average of y. Let's say this average, let's say y1. Similarly with respect to this, with respect to x2, with respect to this block, we have to compute average of y. Let's say it is y2, and let's say with respect to this block, we have to compute average of y. Let's say this is y3, and then we have to simply compute its mean, and it will exactly, it is not y, it is 3. Let me erase it. Yeah, so we have to simply compute its mean, and this is exactly my final prediction for this data, for this dataset, for this entry. This is my final prediction that I will achieve. Now the question that will come across your mind, how I have selected this region, because I am just assuming over here. So how? This sum of square of residuals. So you have to select your regions, your splitted regions in such a way that your sum of square of errors will be your minimum, So you have to select your region in such a way, like in case of linear regression, you will observe whenever you have some, like you have some linear regression, as let's say these are your data points, and you have to select that line so that your residuals, which is nothing my error. So what exactly is error? You will think, what is error? Error is nothing but what I have predicted, and what is the actual value, so this is exactly your error. So you have to minimize this error in your linear regression. So basically you have to minimize this error in your linear regression algorithm using something known as gradient descent approach. Using gradient descent approach, you have to minimize this error. Here my j, nothing but 1 to j. I will talk about each and every term where I belongs to each and every region, and here it is nothing but yi, this yi cap, r is nothing but reason whole square. So this is, I can say this rj is nothing but my r1 reason 1 till reason j. So these are all my reasons. Square of errors, not errors, it is just a sum of square of errors will be your minimum. So whenever you will select those regions as my split region, where this yi, let me talk about this. What is this? So it is nothing but this, it is just a average of y for a particular region, for a this calculation, I guess this calculation, wherever this calculation is maximum, that's a simple calculus, a simple. So thank you guys, have a nice day, keep learning, keep sharing, keep gaining. Hello all. So today in this session we are going to learn what exactly is this KNN, which is nothing but my k nearest neighbors algorithm, which is used both of the cases, whether we have some classification use case or whether we have some regression use case. So it is used in both of the scenarios. But yeah, there is some limitation to this KNN. So what is that limitation? So whenever you have huge data, so whenever you have some huge data, never use this KNN, because it is always advisable to data scientists whenever they are going to work for real world aspect. They are not suggested as, yeah, you have to use this KNN, definitely, because computation wise this KNN takes lot of time. It takes lots of time. So definitely computation wise it is too much costly. So there is not any advantage of using KNN in real world scenario. So whenever you are going to work from real world aspect, whenever you have data in terms of, let's say, GBs, let's say in terabytes, in petabytes, so whenever you have such a huge amount of data, always try to ignore KNN at that particular time. If you don't have that much huge amount of data, yeah, always go ahead with KNN. There is not some major issue regarding that. So let's talk about what exactly is this KNN. What the basics? What exactly the mathematics behind this KNN? So very first, let's understand what is this K. What exactly is this K? So this K is nothing but number of nearest neighbors. Number of nearest neighbors to that particular, I can say, particular data point that we have to calculate, that we have to basically calculate. So the question is how we have to calculate this K. So basically there are two major approaches. The very first one is just use this cross validation. Just use approach cross validation, in which you can go ahead with this randomized search CV that often you have heard about it, and exactly our grid search CV. You can just go ahead with this and put some random value of K, let's say 2, 3 till 10, let's say till 10, and definitely you will get your best value of K suitable for your use case. That's what this randomized search and this grid search will do. So let me consider some very basic use case to explain it in a very easiest way. Let me consider this. Let's say this has some data. Let's say this is data that is plotted over here in your scatter plot. Let's say this is the entire data. You will say, let's say this square shape data and this circle shape data. Let's say this circle shape data is exactly of my, let's say, class 1 or of my level 1. And let's say this square shape is exactly my class 2, or I can say it is my level 2. Whatever you can assume, it's all up to you. Suppose in a future, whenever you are going to work on some project, let's say some new data will come. Let's say some new data, or you can say your test data, You can say it is test data, or you can say it is my unseen data. Let's say this is my unseen data on which I have to do some prediction. Or class 2. So just think how you can predict this, to which class this data points belongs to, whether it will belongs to 1 or whether it will belongs to class 2. So yeah, definitely if you are going to use canon over here, yeah, this use case is just like a piece of cake. Yeah, so let's say you are going to use canon over here to find this data point belongs to which class. So let's say I am going to assume k equals to 3. Just hypothetically, I am going to assume my k value is 3. It means I am going to consider 3 nearest neighbors to this data point. 3 nearest neighbors to this data points. Now the question will arise, how I will compute what are exactly my 3 nearest neighbors. It means you have to use a concept of distance, that what you have often heard in your school days. Because if let's say if I know distance between this data point to each other data point, with each other data point that are scattered over here, I can definitely get to know what are my 3 nearest neighbors. It means I have to use the concept of distance over here. So definitely if you have heard about something, if you have heard about this formula, which is nothing but x2 minus x1 square plus y2 minus y1 square whole square, and this one, this is nothing but just a distance between 2 points, having coordinate as x1 y1 and x2 y2 in some plane. What if I don't have some, let's say I have some this data point is scattered in such a way that it is scattered in, let's say, in n dimensions or in some 3D dimension. So it means let me open a new page. Let me open it. Yeah, let's say this is my data point. Let's say this is my data point, and let's say this is the data point that you have to compute distance between that. Let's say its coordinates in 3 dimensional is x1 y1 z1, and it is nothing but x2 y2 and let's say some z2. And let's say you have to compute distance between both. So simple. What you have to do, you have to just use a formula which is nothing but x2 minus x1 square for your x coordinate. Similarly, y2 minus y1 square for your y coordinate. Similarly, something z2 minus z1 square for your z coordinate. Similarly, if you have n dimensions, it will get expanded. Simple. It's just like an expansion. So this is exactly my Canon also uses, or you can also modify something known as Manhattan distance. So instead of using this Euclidean distance at some particular places, you can use this Manhattan distance. So what exactly is this Manhattan distance? So Manhattan distance is nothing but, you can say it is just my absolute distance. If you have heard, it is just my absolute distance, and it has many names. Let's say what is your city block distance? So this is also my Manhattan distance. Let's say you have heard your L1 normalization. That is exactly your Manhattan distance. Let's say if I will ask you, yeah, tell me, yeah, let's say I am traveling from point Y to point, let's say from point X to point Y. Let's say this is my path, and if I But what if, let's say, let me open a new page. Yeah. But what if, let's say, I have to travel from point X, let's say, to point Y, but via X1, X2, X3. Let's say this is my path. Let's say this is my path, and let's say this is my X1, let's say this is my X2, let's say this is my X3. And if I will ask you, yeah, how you can compute distance between this X and distance between, I can say distance between X and Y, how you can compute it. So let's say I am traveling from point X to point Y, and I am going to say I have to compute its distance. So in such case, in such type of use cases, I have to use our Manhattan distance. I have to use our Manhattan distance, like how Google Maps, you have heard, like how Google Maps and how Ola, Uber uses. So definitely internally they uses this Manhattan distance to calculate distance between two places. That's how they use it. So basically using the approach, how they will compute. So they will compute like, yeah, this will travel from this one, then this, then again this, then this, then this, then this, then this, then this, then again this, then again I am going to travel from this, then again this, then again, and again, and I am going to reach it to my place Y. So in this way they can come up with some distance. So this is exactly my Manhattan distance. Or if I have to explain you in a very layman terms, then I can say, suppose this Manhattan distance is nothing but calculating distance between real vectors using sum of their absolute difference. Suppose, yeah, similar problem statement. Suppose, let's say this is my point X and this is my Y. So basically, this is exactly my Euclidean distance. But going from this way and again going from this way. So whatever it will be, it is exactly my Manhattan distance. Whereas this is exactly my Euclidean distance, and this is, let's say this is my vector A and this is my vector B. So summation of this vector A and B is exactly my Manhattan distance. That's a very basic mathematics behind this Euclidean as well as Manhattan distance. We have something known as Hamming distance. Yeah, we have something known as Hamming distance, which we all are going to cover in our later sessions. That we will basically use in terms of categorical data. So whenever we have to compute distance between some categorical data in such type of use cases, we have to use something known as this Hamming distance. So that's all about the basics of Canon. What is Euclidean distance, what is Manhattan distance? We have also learned the basics behind this. Yeah, what is this use case, what is the value of K, how to compute value of K, basically using our cross validation approaches. And here I am going to assume my value of K is 3, then we have to solve this use case as well. So in the upcoming session we are going to solve this use case. What if we have this value of K, and how you can fetch your nearest neighbor. So that's all about this session. Hope you love it very much. Thank you. Have a nice day.